Matrix multiplication. There are two types of multiplication with matrices. The first type is multiplying a matrix by a scalar, which is a real number. So, for example, let matrix A be A11, A12, A13, A21, A22, A23. Then the product of C, a real number, by A is equal to C times A11, C times A12, C times A13, C times A21, C times A22, and C times A23. In other words, we multiply each element of the original matrix by the scalar C. Let's look at an example with numbers. So let matrix A consist of 2, 8, negative 3, negative 1, 5, 2. Then 4A is equal to the matrix consisting of 4 times 2, 4 times 8, 4 times negative 3, 4 times negative 1, 4 times 5, 4 times 2, or 8, 32, negative 12, negative 4, 20, and 8. The second type of matrix multiplication is when we multiply two matrices together. So let matrix A be the matrix consisting of 1, 2, 3, 4, 5, 6. And let matrix B consist of 7, 8, 9, 10, 11, 12, 13, 14. Matrix A has 3 rows and 2 columns, so its dimensions are 3 by 2. Matrix B has 2 rows, 4 columns, so its dimensions are 2 by 4. In order to multiply two matrices, the number of columns of the first matrix must equal the number of rows of the second matrix. So, to multiply, the number of columns in matrix A must equal the number of rows in matrix B. Now, the number of rows in matrix A by the number of columns of matrix B define the dimensions of the resulting product. So that if I multiply A times B, the product will be a matrix that has 3 rows, 4 columns. So again, let matrix A consist of 1, 2, 3, 4, 5, 6, and matrix B consist of 7, 8, 9, 10, 11, 12, 13, 14. To multiply them, we're going to multiply each row in matrix A by each column in matrix B. So the first element in the product will be found by taking 1 times 7 plus 2 times 11, then 1 times 8 plus 2 times 12, then 1 times 9 plus 2 times 13, then 1 times 10 plus 2 times 14. In the second row, 3 times 7 plus 4 times 11, 3 times 8 plus 4 times 12, 3 times 9 plus 4 times 13, and finally 3 times 10 plus 4 times 14. In the third row, 5 times 7 plus 6 times 11, 5 times 8 plus 6 times 12, 5 times 9 plus 6 times 13, and 5 times 10 plus 6 times 14, or 29, 32, 35, 38, 65, 72, 79, 86, 101, 112, 123, 134. The product has 3 rows and 4 columns, so its dimensions are 3 by 4. Now let matrix A consist of negative 2, 1, 3, negative 2, 0, 1, and matrix B consist of negative 1, 0, 2, 1, 2, 0, 0, 3. So matrix A has 3 rows, 2 columns, or it's 3 by 2. Matrix B has 2 rows, 4 columns, so it's 2 by 4. So we can multiply these, and product AB is found to have dimensions 3 by 4. And we can find the product by taking each row in matrix A and multiplying it by each column in matrix B. So negative 2 times negative 1 plus 1 times 2 is 4. Negative 2 times 0 plus 1 times 0 is 0. Negative 2 times 2 plus 1 times 0 is negative 4. Negative 2 times 1 plus 1 times 3 is 1. 3 times negative 1 plus negative 2 times 2 is negative 7. 3 times 0 plus negative 2 times 0 is 0. 3 times 2 plus negative 2 times 0 is 6. 3 times 1 plus negative 2 times 3 is negative 3. And finally, for my third row, 0 times negative 1 plus 1 times 2 is 2. 0 times 0 plus 1 times 0 is 0. 0 times 2 plus 1 times 0 is 0. 0 times 1 plus 1 times 3 is 3. Now, if I try to take the product BA, that would be taking a matrix that has dimensions 2 by 4 and trying to multiply it by a matrix that has dimensions 3 by 2. But the first matrix has 4 columns and the second matrix has 3 rows. These do not match up, they're not equal, so we cannot multiply these two matrices.